Hi guys, this is Mrs. Smeese. Today I'm going to be reading Unit 5, Investigating Sound Waves and Hearing. You may follow along in the text as I read. We'll begin. Listen carefully. What sounds do you hear? Maybe you hear loud sounds such as traffic or students shouting outside. Maybe you hear soft sounds such as footsteps or the humming of a computer. Some sounds, such as sirens, are high. Other sounds, such as truck engines, are low. Your ears and brain make sense of these sounds to tell you what's happening around you. Why are some sounds loud and others soft? Why are some sounds high and others low? How do your ears hear sounds? Can you hear all sounds? It's better not to hear certain sounds. This unit will help you answer these questions and more. All right, I'll try turning the page here. Now, as I read, I won't be reading the portions of the text in the blue boxes, but I think if you look on the video, you'll be able to see that yourself. Chapter 1, How does sound carry energy? Think about a jet airplane taking off, the wind rustling through leaves, a foghorn blaring over the water, and a pig squealing. These sounds are all very different. Sound is energy in the form of vibrations that can be heard. Vibrations are rapid, back-and-forth movements in matter. For example, when you trip over a spring doorstop, it vibrates, and you hear a sound. Sound energy travels in waves. So to understand sound, you have to first understand waves. A wave is a regular disturbance that transfers energy. Think about water waves. They look like humps moving through the water, and if you've ever been knocked over by a large water wave, you can easily understand that waves carry energy. Sound waves can't travel through empty space. They must travel through a material, such as air, water, or metal, so that they have something to vibrate. Vibrating objects create wave-like disturbances that move away from the object, much like ripples of water moving away from a pebble that is dropped into a quiet pool of water. To hear sound waves made by vibrations, quickly wave your hand right next to your ear. The movement of your hand makes sound waves that your ear can hear. You can easily hear someone whispering in your ear, but you can't hear someone shouting across town. Why is this? Think of the pebble dropped in the water. The first ripples are large. As the ripples move away from the rock, they get smaller. It's the same way with sound waves. When a vibrating object makes a sound, the sound waves spread in all directions. As the waves move away from the source, of the sound, they spread out more. When the waves are spread out, they have less energy and the sound becomes quieter. Instruments such as megaphones can direct and focus sound away or focus sound waves so that they all move in the same direction and make louder sounds. Different types of waves travel differently. Water waves and light waves are sideways or up and down waves, but sound waves are not. They're more like the waves shown in the picture of the spring. In some places, the parts of the spring are closer together. In other places, the parts of the spring are far apart. When sound vibrations travel through matter, they push the particles that make up the matter close together. As the sound vibrations pass, the particles spread apart again. The distance from a point on one wave to the same point on the next wave, for example, from one squished together area to the next, is called the wavelength. On the bottom are the think back questions that are part of your homework. Why can't sound travel in empty space? How does sound travel? How could you use a drum to explain to someone that sound carries energy? That's all for today.